Oh, yes, thank you. Page 8 at the top and page 4 at the bottom. Okay. Sorry, I didn't realize that there were page numbers at the bottom of the page too. So what I like about this booklet, or how it was put together, is that at the very top of the page it kind of gives you the overview main point that they're trying to get across. Okay, so if you're like, hey, I need an example of a one-step equation, or I need an example of simplifying, then you can flip through and you can see, oh, here's one. Okay, I can look at these examples. Okay, so here we go. Bum, bum, bum. Page. Come on. Okay, so use this pen. There you go. A two-step equation means that there are two things happening to x. Okay? Page 8. Yep. So, to isolate the variable, so we want to get x all by itself, you do the reverse order of operations. Okay? And we already know that. I think we called it PEMDAS. You might also be familiar with BEDMAS. Whatever works for you. Okay? The big thing is that we have to do the opposite. Okay? Okay? Good here. Good here. There you go. Reverse order means undoing adding and subtracting first, and then we're going to undo multiplication and division. Okay? So don't forget, we have to keep them balanced. Whatever we do to the right side, we have to do to the left side. Okay? So let's try an example. I'll zoom in here. Okay. Minus 2x plus 3 equals 7. So the first thing I'm going to do is I'm going to make myself a little table. Because as I'm adding more steps, okay, the table becomes a lot more helpful. Caitlin, what is the first thing that's happening to x?
It's getting times by -2.
Right on. Okay, so it's being multiplied by -2. Bowden, what's the opposite of that? What's the opposite of multiplying? Yeah, right on. Is that what she said? Oh yeah, sorry. That fan that's over top of me is just quite loud. Hey. Kurt, what's the next thing that's happening? Okay, right on. It's being added to 3. Okay. Kelsey, what's the opposite of that? Yeah, right on. Okay. So as we constructed our equation this way, to deconstruct it, we'll start from the bottom and work our way up. So, first step, we're going to subtract 3 from both sides. And if it makes it helpful for you to draw a line, so you remember, okay, yeah, I have to make sure I do 1 on one side and something on the other side. No problem. It helps me. It's nice. Okay, now plus 3 and minus 3 are going to cancel out. So on the left side, I still have -2x. And on the right side, Cheston, what is 7 minus 3?
4.
4. Perfect. Okay. So next step, so we did this step, done. Okay, next up we're going to divide by -2. So if I look here, I'm going to use the horizontal line to write division, not the symbol division. We're going to use the horizontal line. Because as our equations get larger and kind of more complex, this helps separate everything and keep it all straight. Okay. -2 divided by -2 is 1. So that just leaves us with x. Jesse, what's 4 divided by -2? -2. Perfect. Okay? So now we're just going to check and make sure we got it right. Okay? So I'm going to go in and check it. So I'm going to write down the original equation. So 2x plus 3 equals 7. And then wherever I have my x, I'm going to replace it with minus 2. But for you guys, I'll put that in color. Plus 3 equals 7. And then I'm going to simplify. Okay? So I'm going to look at my left side of the equation, and I'll work with that first. Minus 2 times minus 2 is 4. Plus 3. Okay? 4 plus 3 is 7. Good. Okay? So I've solved the left-hand side of the equation. Now I can go to the right-hand side. Oh, well, I don't really have to solve anything. I can just keep bringing that 7 down. Left side equals the right side. Game on. Okay? You try the next one. Okay? I'm going to write down my answer. I'll keep mine up here so that you can see. But you write down your answers, and I'm going to come around and see what you did. Okay? Make a little table, the construct and deconstruct table. Okay. And then when you're done, plug your answer back in and see if you got it correct. You shouldn't get weird fractions as answers or weird decimal places as answers. If that's the case, that's normally a good heads up that something's not quite right. So if you're getting like negative 2.197, then something's not quite right.
Right, so what's that divided? Okay. Okay, I understand that.
Okay.
Whoa, but that's not right. That plus that is not right. So something here, here would be oh, that is your point. Yeah. Okay, that's looking good.
arithmetic. Your work is right, but the arithmetic.
So I did that, and so why did I multiply that? Well, first you're gonna have yeah, it's 409.
You just might need more space.
Back to page 4.
Yeah.
So that's good. And then what you have here is just that 11 minus 3.
Yeah. That's gonna be, it looks like it's just mainly small arithmetic things, but otherwise the work looks really good.
So you added, subtracted from both sides. So over 2 equals, so it's 11 minus 3. Yeah, so that should be a point. And then one more time. Oh, we rewrote it, okay. So then we should have 2 equals 8. And now you'll do a multiply by 2. And then we'll get
just some small arithmetic stuff. Yeah. Nice on yours? 11 minus 3 is at 9. So the work is good. It's arithmetic there. And there's where your arithmetic is. Check out Kelsey's. Kelsey Carter. Okay, so this is good. Now, we divide it by 2. Divide by 2. And then times. Okay, I'm gonna unmute this here, or unfreeze this. Okay, so I like what I saw, right on. Okay, so I'll point here, seeing as I'm doing this for the people who aren't here. Okay, so I like that I saw the tables. Excellent, right? That helps us keep track of what we're doing. I like the -3 and the -3 on both sides. Okay. The big issue, or the big thing that I saw lots of people, just arithmetic. 11 minus 3, lots of people put either 11 or they put 9. Okay? So sometimes it's just working too quickly, or counting it through, or thinking it's one thing when it's not. So just be careful, because that's the only issue, right? That's really the big thing that I saw. Then we have divided by 2, so the opposite is multiplying. So we have to multiply both sides by 2. Then we get 16, and then we plug it back in. Same thing here. I saw People had 9 plus 3 equals 11, okay? But that's 12, okay? That would tell you right away, uh-oh, I made a mistake, and then you'd have to go back, okay? But I like it. It's good. It's just a little bit of arithmetic. The algebra is looking pretty good. Tegan, sorry, we just finished page 4. But we'll catch you up, okay? You turn the page. Let's try, we'll add a little bit to that, okay? Number okay, next one, a flow chart, which is what we're already doing. We do that construct and deconstruct table. Okay, that's the same thing we're already doing, okay? So flow chart can be used to help you organize the order in which you need to solve. So this is the whole story of X. This is what we've already been doing. It's just this person put the notes to it over here. So that's totally fine, okay? I'm glad we already do it because it's very helpful, okay? Okay, so let's take a look at the first one. I'm going to make my little table here. Construct, deconstruct. And when I look at the equation, Kieran, what's the first thing that's happening to X? Right on. Okay, so we're being multiplied by 3. Carter, what's the opposite of multiplying? Right on. Okay. Also divide by 3. Ariel, what's the next thing that's happening to X?
Minus 4.
Right on. Cheston, what's the opposite of that?
Plus 4.
Right on. Okay. So I'm going to try this out. Remember, I'm going to start at the bottom and work my way up. Okay. So first thing, I'm going to add 4 to both sides. Okay, so when I do that, my minus 4 and my plus 4, they cancel out, and I'm left with 3x on the left. And on the right side, I have 9. 5 plus 4. And if you did the arithmetic incorrect and by accident you put a 10 here, then your next step would feel really weird because you'd be like, oh, 10 divided by 3, that's not going to work out very nice. Or if you had an 8 and you just went the wrong way, right? 8 divided by 3, well, that's not even a nice decimal, okay? Something's not right. That's a good way to red flag and say, oh, I think I've made an arithmetic error, okay? So next steps, we did that. Next one, divide both sides by 3. I told the other class that there won't be any decimals, but there are. But there's like 0.5. If you got anything weirder than 0.5, then I would say, oh, we made an arithmetic mistake. Are you good, Jack? Just put it on my table there. It's good. Thanks so much. Okay. So now that we're at this step, our 3's are going to cancel out. Okay, so on the left side I have x, and on the right side I have 9 divided by 3 is 3. Okay. So now, let's check it and make sure we got it right. So I take my original equation, 3x minus 4 equals 5. And wherever I have x, I'm going to replace that with 3. Okay, Alyssa, what's 3 times 3? 9 minus 4. Julian, what's 9 minus 4? 5. Perfect. There we go. Okay, I want you to try the next two. But I want to point out something. Okay, this one right here, it has a negative x. There's a couple ways that you can solve that. Okay, whichever way you do it, you'll be able to know if you got it right. Okay, because we'll just check our answer. Okay, but just pay attention because you might be like, oh, that looks weird. That's okay. You can either move x to the other side so you have a positive x, or you'll just have an extra step. Okay, so give it a try. And I will, yeah. You sure?
No, but maybe, you know. Yeah, it will minus x plus 5. No, minus x plus 5. Yeah, just don't forget about that negative.
Yeah, and you can also add and do like that easy.
Yes, yep, you got it. Yep. Okay, so
Okay. I'm going to write my answers at the same time. Let's see if I can. Okay, good. You don't know what to add? Well, what's on the other side? There's also what? What's also on the left-hand side? Did you find it, Kelsey? Just moved it around. So now you have a positive variable instead. Yeah. What I like about using that table too is that if you make a mistake in your algebra, the table can kind of help you say, oh, watch out, because if the next step doesn't look right or doesn't make a lot of sense, then you just have to go back a step. Okay, let me come and see what you're doing. That one doesn't have anything on it. Hey, right on. Nice job. Yep, there's a couple ways to work that one. Okay, so then let's take a look at that middle one. And, yeah. And I'll show you both ways to do it. Okay, so let's take a look at that middle one and I'll show you both ways to do it, both ways to look at it. So I'll unfreeze. Okay. Option number 1 is we make x positive. Okay. So option number 1 is we make x positive. And in order to do that, I'll zoom in here. Okay. If we have a negative x, we just add x to both sides. Right? Because it's a teeter-totter. Whatever we do to one side, we have to do the other. So if we want to get rid of that x, we can just add x to both sides. That would cancel the x's on the right, so we'd have 5. And now I would have 8. And now this positive x. Okay? Now everything's positive. Oh, just so much easier. Okay? That might be how you like to look at it. Totally fine. Now it's just a one-step equation. The only thing happening to x, we're adding 8. Okay? So in order to get rid of it, we're going to subtract both sides by 8. Okay? Which gives us x equals minus 3. Okay? Or, this is me checking it. Okay? Or, let me write this out. 8 equals 5 minus x. Okay? This is the option that lots of you chose. Okay, we work with the negative x, but if we do that, we have to recognize that negative x is the same thing as writing negative 1 times x, which is an easy thing to miss, an easy thing to forget. Okay? So when we do that, and we take a look at what's happening to x, Riley, what's the first thing happening to x? By what? Careful. By? Yeah, it's being times by negative 1. So when we deconstruct it, we're going to have to divide it by negative 1. Ariel, what's the next thing happening to x here? Okay, so we're going to have to subtract 5 because right here we are adding 5. Okay, so if you took this method, the first thing we would want to do is subtract 5 from both sides. Okay, so 8 minus 5 is 3. Plus 5 minus 5, well, that's 0. And then we're still left with minus 1x. Okay, but I did that step. Now I have to divide by minus 1. Divide by minus 1. Divide by minus 1. The minus 1's cancel. And I have x equals minus 3. Notice how we get the exact same answer. Exact same answer, but we took 2 different approaches. And they're both totally fine. They both work. Okay? And if you plug them both into the equation to check and see if you got it right, both times you would get 8 equals 8. Okay? So it's just a matter of which one works best for you. What are you more comfortable with? I think most people are more comfortable with this after we move the variable around. It's just this step here that was the initial roadblock. But for us here, it was this having the negative sign in front of the x that was the big one. Okay? Okay, turn the page. Okay. To make sure you correctly solved for x, you can check your work. Okay, we already know this. We're just going to fill in the blanks. This is nothing new. Okay? To check, I don't know actually what goes in that blank at all. Put the answer for the variable back into the original equation. Okay? Then we're going to simplify each side. of the equation, and if both are equal, okay, then you know that you are correct. Okay, so we already know this stuff, right? We've already been doing this, we've just now put it into words. Okay? Okay, I want you, hold on, let's go to the, no, let's not do that. Okay, I'd like you to try these three, okay? I'm gonna put up the questions on the board, and as soon as you're done the three, I want you to come up and solve one of them and show your work, okay? That way we can, when you're done, you can go and check and see what we did, okay? Take a minute, write them down.